Yes, sir, you are audible. Am I audible to you, sir?
Good evening, sir.
Hello. Good
Hello.
evening.
Hello, good evening, sir.
Shall we start, sir?
Recording solid.
Good evening. Am I audible to all?
Yes, sir, you are audible.
Yes, sir. Good evening.
Yes, sir. Yes.
Good evening. So should we start or we have to wait for some time?
Good evening, sir.
Yeah. Good evening.
We can start, sir. Okay. So, good evening, everyone. A warm welcome to all the participants. And today's our renowned speaker, Mr. Nikhil Padte, sir, for the 6 days online FDP. Of ATAL AICT Training and Learning sponsored faculty development program on design thinking and innovation organized by Department of Mechanical Engineering of Sant Gajanan Maharaj College of Engineering. Once again, on behalf of Sant Gajanan Maharaj College of Engineering, I heartily welcome all the participants and today's our esteemed speaker, Mr. Nikhil Padte, sir, founder, Jang's Technologies, Itzelkaranji. So let me briefly introduce today's our speaker. So speaking about the qualification of this sir, sir has completed MTech in Manufacturing Technology from IIT Bombay with 99%, 9.886 CPI. and sir has been awarded with most outstanding student and technical person of the year at IIT Bombay. Also, sir has been awarded winner international and national robot competition in his college days. Received best student award and was Shivaji University rank holder in BE Mechanical. So, sir has a very good academic record. Speaking about the professional career of this of Sir, Sir is the founder of Jangs Technologies in 2014, which manufactures Industry 4.0 ready smart inspection systems, automations, and machines. With a team of multidisciplinary knowledge, one can get complete technological solutions under one roof. Before founding Jangs Technology, he was a partner in Microsoft, a company manufacturing machine tools, automation, dies, and production of brake pistons. He has also worked as a design engineer in General Electric in the field of aviation and energy after post graduation. Now we briefly take the review of the award received by Mr. Nikhil Padte sir. Sir has received most prestigious state level award named Young Achiever Award, selected from Maharashtra and Goa state for his innovative and indigenous work in the field of intelligent software, food processing systems and foundry technology. Sir has been also awarded as Navasankalpak in the field of business by Sakar newspaper. He is awarded with K Knight on the Town Award for innovative ideas and nominated for Debutant of the Year. Awarded as Yuva Gaurav in the field of business by Giants Group Central and Saheli. Received a Rashtrapati Scout Award from Dr. S.D. Sharma, President of India, at Rashtrapati Bhavan, New Delhi, in his school days. So, after going through his brief introduction, we can say that we are very honored, we are very privileged to have such an eminent, knowledgeable speaker with us. So, without wasting time, once again, I welcome Mr. Nikhil Padte sir and all the participants for today's session. Hope all of you will enjoy today's session. So I request Mr. Nikhil Padte sir to please start the session. Over to you, sir.
Yeah, good evening. Uh, First of all, very much sorry for delaying the session by 3 minutes and due to some technical hiccups. I think I'll just start with the presentation itself. Will be presentation. Just a minute.
Sir, voice is buffered actually.
Uh, is my presentation is visible?
Yes, sir.
Yes, sir.
Yes. Yeah. So I think the topic is the rise of technology, which is conveyed to you already. And here uh, I represent Jangs Technologies. That is my own company, which is from 10 years back. And the intention was to have all these some good technologies to be developed within India, and that too sitting in Karanji, means, rather than going to any metro cities. Because what I found that in our region, means mainly for Kolhapur region, I'm talking about, very bright and brilliant people are there who likely to travel to Pune, Mumbai. So we thought, why not to have a technology-oriented company in Karanji. And when we started this company, we started with, of course, technology. That's why the name is Giant Technology. And we started with a basic electronics where we are just measuring the force, and slowly we have reached up to AI based technology. I just want to show that journey to you and how the things can be done by sitting in Ichalkaranji kind of area. We can touch upon the latest technologies due to all this world is connected. So where you are doesn't matter. What you know, that matters a lot. So we'll start with the presentation. Already my all profile and details is conveyed to you. Whenever I start my presentation, I dedicate this presentation to my parents, that is I and Baba. Both of them are not there now. And of course, I dedicate that to all my professors, but especially Professor Dr. N. Ramakrishnan. He was a guide for me in IIT Bombay. I think 1980 is what he did his PhD. And now he is Professor Emeritus in IIT Gandhinagar. And I think just 1 month back, he also, said that he will stop teaching due to the age factor. What I learned from him, when I went to IIT Bombay and when he assigned to me as a guide for my master's degree, and the day I met him, the first sentence he said me that, Nikhil, I'm not going to teach you any technology. It was really quite, contrasting to me that I am in IIT Bombay and professor is saying that I'm not going to teach you the technology. Then he said, now onwards, I will teach you how to be a good person in industry. Because technology you will definitely learn being in IIT. But when you learn something, as we say, the Vidya Vinay. So similarly, he said that the technology is one part, but you have to be simple with the technology. So let's talk about the automation. Automation is, it's a very simple word. When we talk about automation, let's say 20 years back, yes, something was happening with the automation. But now automation is the most simplest thing that you can do. This is a very funny picture where, even farmer want to give fodder to the cow in an automatic way. So that is what the mindset was there when the automation is, started in India. That too, let's say in 2005, 2006, we used to hear about all these CNC machines, that is computer numeric control. They are coming up and we have become a best hub for manufacturing globally due to these CNC machines. But after that, what we found with people operating CNC machines, we cannot get that efficiency. When we were supplying to Brembo company in Italy, we used to calculate all man hours, then you have to give time for tea, you have to give time for rest, everything. And there, even though automation speed is less, it was performing better than human. So slowly we decided that why not to go to automation. So that is one kind of loading and unloading automation or process automation. So that journey started nearly 2005. So we have developed these kind of machines, whatever the image you are looking at. All these machines are, this is a 3D model, but real machines are, manufactured, assembled in Ichalkaranji, that too in 2000, I would say 2010. So 2010, we could manufacture special purpose machine, rotary stations machines, gantry machines. That is, this is twin gantry, one gantry, both the gantries. That gantry means it is actually loading and unloading the job from the machine, and even doing a lot of stuff like, let's say, inspection, measurement, and even packing. Everything is done through this gantry system, similar like a robotic system. And for these gantry system, you need to have a linear production line. So these machines were running nearly 2010 in Ichalkaranji. So such kind of technology growth was happening. 2006, 2007, we were hearing about automations. People are using these automations, and slowly, you can see all these real machines, whatever the image you have seen. And I will just show you. This is the small automation what we have done. This is rotor oil filter which goes into two-wheelers and four-wheelers, and the loading of the parts was done through automation. Let me check. Then these are the gantry systems which were running in my own company that time when it was developed first time. You could see the specifications that the speed, accelerations, it's more than 1G, means you can say it is nearing to the acceleration of a rocket. Rocket usually accelerate with 1G, 2G. So similarly, these machines were getting accelerated, and the travels and up to 6,000 mm also you have to position within less than a 10 micron. And in that video, you could see that it is totally unmanned. Two machines, it is getting loaded, unloaded, and passing one part to other machine and unloading it. So all these systems were running, as I said, let's say 10 years back. So similarly, we have developed some, different type of casting processes. This is all automation, right? It's a very basic way of doing this. Vacuum investment casting, where we use usually in casting, there is a mold. So in that mold, people put liquid material, and it goes with the gravity or maybe pressurized. But we have, designed a system where we used to fill up the molds through vacuum. So due to which you get a more yield, I would say. I'll just show you all these videos later. So this is once again CNC lathe machine loading and unloading system. And for your knowledge, this was a BE project. So this is done through a last year BE mechanical student. This is fully pneumatic. So we started with doing all such kind of small
Good evening, one and all.
Sorry, yeah. Any questions? Hello?
No,
Hello?
continue, sir. No problem.
Hello?
Yes, sir, you are audible.
Yeah. So
Yes, sir.
I think somebody is asking any question.
Yes, sir. Sir, just one request, sir. Hello.
Yeah.
Sir, just hide that Google Meet bar showing at your presentation so that the
This one?
presentation will be seen.
Is it okay?
This one. Yes. Yes, sir.
So then this is the way such kind of automations where no intelligence is there in that, and only these are getting operated through some fixed logic, and we were trying to have higher speed, more precise, so that we can have production quantity, means we can increase the production quantity at the same resources. So similarly, we started with such kind of thing. And then what means I understood that only automation cannot do the things, most of the time in industry, what happens, people do uh, Kaizen. Kaizen means some improvement. And what we found through experience that Kaizen is the best. So doing small improvements doesn't, leads to your aim. Then we decided we should have all the technologies under one roof. So what all the technologies are needed for a manufacturing unit, let's say. I'm just focusing on auto sector manufacturing. In that, if you look at, we need to have inspection system. So when we talk about inspection system, that means air gauges, LVDT probe, and you have to measure dimensions, material strength, again material hardness. So everything comes into inspection systems, and a lot many things, means color, shape, and those are there definitely. That is vision measurement system. So we first decided let's have inspection system developed. Then once it is done, the next task was, if you want to analyze all that thing, you need to have data acquisition. So then a data acquisition means whatever the inspection values were getting inspected, we have to store those into a database with as a classified data, and that too with the biometry. Means let's say if whoever is doing that measurement, that we called it as a traceability. And there is one more is term comes in all manufacturing, that is root cause and traceability. Means whenever a product gets manufactured, it has to have full traceability. Means from day one up to it is going into any two-wheeler part, what all process at what time, at what environmental condition it is manufactured, everything is recorded. So it is called traceability, and that is the new term which is coming in all manufacturing sector. And with that traceability goes a root card system. Means on that card with one unique number, everything gets recorded. So that is what data acquisition and biometrics. And slowly, people were started thinking about manless STM. As I said, I just showed some slides before that manless production was happening on two CNC-less machines. Similarly, a totally manless industry people are talking about nowadays. So that is called cyber industry. Have you ever heard that in world that is there any company which is totally manless? Have you heard about that? Anyone?
No, sir.
Okay. So how about you are aware of FANUC controller system? Means let's say a CNC machine which runs or controls through a controller, which company's name is FANUC. So you can write down that name, that is FANUC. So when we talk about CNC controllers, which goes into CNC machines, they have a company in Japan, which is manless company. That all these controllers are manufactured without a person, whole automatic system. And the plus point is it runs 24 hours. You don't need a light inside a company. Are you getting my point? So much of less power is required because machines can work without light also. Means I'm saying the light means bulb and this kind of power is required, of course, but they are running 24 hours, and whole data and everything is getting on their desktop. And nowadays, slowly, you might be knowing that already, that computers are also getting absolute. Everything people want to have on mobile. So how this happens, we will discuss further definitely. I'm just giving you some, basic thing and getting into that direction. So once, as I said, manless system automations are coming in picture. The next thing was smart system. So what do you mean by smart system? Let's say your mobile. Why it is smart? Any answers? We say mobile as a smart device. Why?
Sir, because mobile is run on the basis of algorithms.
Yeah, or you might be having very smart students with you, right? So what do you mean by smart student or smart device? See, okay. So when we talk about smart means that system should collect whole data. That system should send that data for the analysis by itself, and that same system will receive the decisions after data analysis, and it will work according to whatever the decision is given from the analysis. It will work according to that. So that is called smart system. Means like your mobile, when you use anything on the mobile, it is getting recorded at the background, and then it goes to the cloud system, what we will discuss later. It goes to some sort of database, there it gets processed, and it analyzes your behavior on the basis the way you are operating the system. And again, it starts suggesting you something, okay, we can do this, we can do that. So this is called smart system. And when this point has come in picture, that we have to make a smart system, then the revolution is started, that is called Industry 4.0. That means initially, let's say if any machine, if you want to connect to internet, you need to have a computer, then connect, that machine to the computer, then computer will connect to the internet. So many things were there to do that. So nowadays, only a single chip can directly connect to the internet and send data directly from machine to the internet. So we will discuss that. Before that, before this Industry 4.0 revolution, there is one more term comes in picture, that is SCADA. SCADA, that is data acquisition system and supervisory control and data acquisition system. So SCADA means what? In a company, I'm not going to the internet, but within a company, I am connecting all my machines and getting that data on my desktop, and that is at the local level. So the SCADA started like that. So from my desktop itself, I can start the machine, I can change parameters of the machine, even, I can see the status, everything by sitting in my cabin. So that was again the foundation for Industry 4.0. And rest of the things you might be aware of nowadays about these OTPs, auto email, which is currently happening in everywhere. So that is also required. Let's say whatever the production happens, I need not to go to again to the desktop. It has to come directly to me. So this is what the whole seamless connectivity I am talking about. And it is started with Industry 4.0. So when we talk about this new revolution, there is a slight impact that eliminate the jobs in which computers outperform humans. What it means, see, whatever the rise and the impact is happening, we have to think in a way that when we talk about humans, humans are the brilliant people on earth, right? So humans are not, made for doing some repetitive work or doing some cleanly work or something like that. So the things which are getting more repetitive, we can easily hand over those things to the machine. So similarly, on that principle, this Industry 4.0 started, and the impact is so much that when we talk about human to machine ratio, in 2020 it was 67% human were working, and machines were doing 33% work. But slowly, I'm again talking about repetitive work, not all kind of work. But when we talk about repetitive work, definitely this percentage of human will go up to 10% with this AI, things is happening. And people are focusing to make it 100%. But we don't want, any repetitive, boring work to be done by humans. Humans are intelligent. They have to do some innovative work, some fresh work, some new technology things, and that is where the world is going. So, so that is what the line, chance to work on something better, right? So, so let's say I'm just, giving you the slide of Industry 5.0 and Industry 4.0 and 5.0. The only difference is in 5.0, we add innovation, waste management, customization, and humanization. And all these black words are Industry 4.0. And, when something comes from European countries or Western countries, it comes with very jazzy and good names. So when we used to heard about this Industry 4.0 10 years back, these all words, CPS, smart, IoT, AI, cloud, big data, we thought it's a very big thing to do. But when we understand the basics, it is very simple. So I'm just giving you a simple idea that how all these things work. Okay. So as I said, I have an automation, which is a person is sitting here, but that person needs to operate still again by the remote. So that is automation. Means every time a person intervention is required, then what is Industry 4.0? You take any machine and add a system where it reads all the data of the machine, and one chip is there which directly sends that data to internet. I'm just saying internet. I just say it is called to the cloud. So cloud is something like a big data on the internet, right? So any idea, one more question, that where is our all data goes when we talk about cloud? So cloud is a data which is stored on internet. So anybody has idea where is that data physically available? See, something goes to the internet means it has to store somewhere, right? Any thought?
Sir, it will be on the
Prabhu,
server that is provided the provided space by the cloud service providers.
correct, but where these servers are situated? See, if it is a local network, we can say this machine is there where all data is, physically available. So similarly, where all these servers are available in world? See, you all use Google Drive, right?
Yes, sir.
So whenever you put something on Google Drive, so where is your data? In, let's say, in a globe, where is your data? It's not in your house. So it is getting somewhere, it is getting, uploaded. Okay. So I will just, tell you where it is. So have you heard about maybe let's say 5 to 6 years back, Microsoft said that they are, putting all data centers inside the ocean. Have you heard about that? Anyone?
Yes, sir.
Yes, sir.
So, yeah. So it is called data centers. And why all that data is stored inside the ocean? Very deep inside ocean.
Dissipation of heat generated. Maintain
Correct.
the low
So
temperature.
whenever we, yeah, perfectly right. So whenever we, do any data queries or whenever we upload data, we are increasing the entropy. So that is called, we are, increasing the heat, and that heat, all that heat has to get dissipated, and due to which they, drench everything inside the ocean. So they can take a benefit of cold water, which is at very high, bottom of the ocean. But few companies have their data above that. So that is where they have to do all these cooling systems. And the funniest part, let's say if your uh, Google Drive, whatever the data you have uploaded, if it is in somewhere, let's say in America, and something happens in America, what will happen to you? And that data center whole is burned or gone due to some mishap. So what will happen to your data? Any idea?
Data may be lost or it may be saved if we make a replica of data.
Correct. So loss is not allowed. Let's say if your banking data is in America data center and something happens due to all these wars, so your bank balance will be zero, right? So it's very difficult. So as you said in later part, that the replica. So I just want to know, Ms., what are your thoughts? How many times it is getting replicated?
Not sure, but it
Only
may be
one,
2 or 3 times.
2 or 3 times, right? See,
If we consider
after
for
looking at
that
all our,
storage capacity.
yeah. So it is not only 2 and 3 times. I just want to put it in this way, that whatever the data is there, let's say all Indian banking data, we have our own data centers where we put one copy, another copy, and nearly more than 10 times this data is copied at different geographical locations on the earth. Because let's say if some seismic or earthquake happened in India, that data after that it has to be retrieved from somewhere else. So at different geographical locations. So where let's say Indian data will be available in America, and the same data will be copied to somewhere in China data center. Same data will be copied to German data center. So it's problem, right? That our data is in different countries. So what to do? That means Indian people have how many money that data is with the different country. So what is the solution for this? Okay. So the solution is very simple. We call it as an encryption decryption, that you already know. And whatever the data is stored, it's all encrypted. And when we encrypt data, it is called key encrypted, means which is also automatically generated on time basis. So due to which your data in cloud cannot be read by anyone. So whenever you connect to the cloud, it is called API key. So through API keys, we can connect to the cloud where it again decrypts the data and send it to us. So that, encryption, decryption security is already inbuilt in all this data. Okay, so next word is big data, because, we are capturing this data at every second, sometimes every millisecond, microsecond. So you might be knowing that, let's say, we make a movie of about 3 hours, it's in GB, right? One movie about 3 hours, let's say 600 MB or 1 GB. And if I'm capturing worldwide so many data every time, so anybody has an idea that what is the maximum integer number that we can produce? So just keep this in mind. You will come to know whatever that integer number is there, it immediately overflows. Means we immediately cover within 10 minutes. So a different strategy is taken while storing this data, and that is called big data. The second is CPS, that is cyber physical systems, where, as I said, that on machine we are putting some Wi-Fi chip and getting the data, then it is called as CPS. Of course, once data is there on internet, on cloud, it is very easy to process. The point is, when I keep that data in my computer, buying that high efficient calculation computer is very much costly affair as an individual. But if that data is in cloud, you can buy some services monthly basis, or even for yearly basis. You can use and do your calculation with the speed nearly matching with supercomputer. So that is possible at very less cost. So I especially, recommend all of you who are doing some research on data calculations and all, you can upload your data, or let's say FEA analysis kind of things, or CFD, that is computational fluid dynamics, where a lot of time is taken if you are doing it at a local level, rather than if you upload your model on cloud and do that thing within the cloud, you will get the fast results. So that is why, all these analyses are happening so fast. You might have seen, last 2 to 3 years, the calculation time, the optimization time is so much reduced, because everything is happening on cloud and by using data analytics. So once this is done, what we found that even though we have collected the data and we have applied some machine learning algorithm and it is giving some results, but till then, whenever you get something from the AI, it is in percentage. AI says, that 60% it is car, or 70% this is human, 90% this is something like, value comes from the AI algorithm. That means after that, still humanization, that is human decisions are required, what we felt in Industry 5.0. That means whatever analysis is done, still some decisions are required from the human. And of course, innovation is not a part of AI, but I don't know in future what will happen, but still our brain is the best thing to do innovation. And when we talk about all these things, so much of data is getting transferred, so much of heat generation, so much of electronic utilization. Electronic waste, even so much of, population increase. Everything on the globe, when we talk about, more than creating resources, we are creating waste. So waste management is taken, as a prime thing in Industry 5.0, where e-waste to all types of waste will be managed, and a different kind of protocols, different kinds of systems will be used in Industry 5.0. Are you clear about Industry 4.0 and 5.0? I hope so. Any doubt?
No, question is clear. No,
Okay.
thank
So this is the new term that is called digital twin. So what it means, that this is again a part of Industry 4.0. This means just consider that you as a person, I have a total 3D model of you, and I am recording all your heartbeat, your blood flow. So everything is getting recorded through the devices, which is, maybe within body or maybe, on the surface. And we are monitoring the whole health of the person through computer. So it's like a digital twin. Or in a machine term, let's say I have a machine in a shop, same 3D model is created. I am capturing all its motion as a real time. When we talk about real time, that means I am minimum, there is a threshold that real time means at least I should capture 10 samples. Is it correct? To our eyes, it is 24 samples per second. So if we collect so much of the samples real time, then it is that is called real time. So let's say I am capturing the data of motion, machining parameters, loading unloading parameters, and if I could see the whole this particular manufacturing system here on PC, then it is called digital twin. Benefit of digital twin, that I can control everything remotely. I need not to be within the company. As I said initially, the Fanuc company, which is cyber company people talk about. So there, everything is getting recorded and everything you can see by sitting at your home, and you can take a decision if something is needed in between. So that is called digital twin. So, I heard a very funny story when, that is maybe 15 years back. We used to have those kind of messages that if you want to order a pizza, and when you say that I want a pizza, the pizza guy will let you know that no, sir or madam, your cholesterol level is this, so you cannot go for this kind of pizza. Then that person says, okay, just forget about pizza, give me coffee. No, last 2 days, your sugar level is high, so you cannot go for coffee. So something will happen if this digital will really work. That finally, whole person health consciousness comes in digital twin. Similarly, in machine, there is one more term coming up in these days, that is machine health monitoring system. So what it means, when you send your car for the servicing, sorry. So when you send a car for a servicing, that guy says, okay, you have to change the oil, or you change your brake pad, or because your 10,000 kilometers are done, or now this is required. But if we go for a digital twin, if sometimes if your brake pads are getting damaged before 10,000 kilometers, this digital twin will say you have to replace it. This is called preventive maintenance. Or if your brake pads can be used due to your good driving skills, it can be used next 5,000 kilometers, then it will say you don't change it. So you could see the benefits, you're capturing the safety that not every time you have to change at 10,000. If it is getting damaged, you change it immediately. Or if it is not getting damaged and if it has a life, you can extend it. It means through this digital twin, you can use everything adds to the fullest of the life, not in between you have to replace. So this way, this also reduces the waste on the earth. Sometimes we are scrapping the things even though they have a life, but we just scrap with whatever the standard way we do the service. So maybe some cars nowadays coming with servicing alarm. So the car itself tells you that okay, now you have to go and change the brake pad. You have to go and change the oil. So in future you will get these kind of machines where they monitor their health by themselves through digital tools. And while doing that, the company are already monitoring. When you look at connected car nowadays, internet connected car, the new models are coming up. So company already aware of that what is happening to your car. Means I'll just give you one example that this water purifier coming with Wi-Fi connectivity nowadays. Even I have one in my home. So they monitor and they directly send service persons to us that your filter life is now less than 10. So you have to change. So how this happens? Because they are recording your water purifier data continuously to cloud. And from cloud, that particular company, the supplier of the company, monitors, they run their own AI algorithm and they create their own trigger. See, you look at how the things are happening. There is no human in between. This water purifier is sending data to the cloud. There is an algorithm which is checking all the water purifiers what they have supplied on the earth, and that whole data is getting analyzed. If something is needed to some machine, that trigger will generate it. I'm just talking about all these words, trigger. So this trigger gets generated and that goes to the respective person which is near to that water purifier, and that person comes and repairs your system. So this whole thing is already in place. Next time if you buy something, go with the Wi-Fi, cloud connected devices. All these free water purifiers, AC, nowadays you can get through all this connectivity. So you need not to worry about your device, and even not by company. Everything is happening through algorithm. So maybe I would say 8 years back, we decided to start with SCADA. As I said, that is what the entry point for all this AI technology. SCADA means first is to have a data acquisition. So we have developed some SCADA systems. This whole software is written by by all engineers who are in mechanical, electronics, and software. So this system controls whole process industry. That is coating on the material, the plating on the material, zinc plating or phosphating or even hardness treatment cycles. So this software one can control from anywhere in the world. So this technology growth, connectivity is started, let's say 10 years back, and tremendous good results. Here, no decision is taken from the software. It only records the data, and whenever the person gives some decision by analyzing the data, it was working according to that. So again, in between person was needed. So similarly, we did it for CNC shop, where it additionally includes SCADA plus biometric systems, plus automatic SMS sending systems, data analysis. And now, if you are aware of, let's say, CNC machine, whenever there machining happens, the tool wear is there. Slowly, the tool on the machine gets, reduction in the dimension, due to which the dimensions of the job keeps on changing. So our system, what it does, flight intelligence, that whatever the job is getting manufactured, it starts measuring it and it maintains the track that how the tool inside the machine is getting wear. On basis of that, it gives compensation to the machine and it tells machine to correct. So that what we found with our system, actually about 2% of rejection has gone down to 0.3%, and that is huge amount. Means when we have implemented to a very huge production company, our return on investment of our software. Hello. Sorry. So our return on investment, what we call is a ROI, has covered within 6 months, and they were very happy that only by making a servo loop kind of system where whatever the part is getting manufactured in the machine is automatically measured, and on the basis of dimensions, not only one job, but previous all job data we are analyzing through AI, and we are predicting that next job will come with this kind of dimension. So better you correct the machine with these kind of. So all these things are happening, and we are getting really good results. And not now, we are supplying these systems for last 5 years. So we are exposed to AI, let's say 6 years back itself, and we are doing our own. We are implementing our all this technology in our product, and really we are getting. So my question to you all: so when to use AI? In engineering, when to use AI while developing engineering applications? Any abrupt thoughts?
Sir, when lot of data is available to make a algorithms, then we are using the AI.
Any other thought? Okay, I'll just put it in a very simple way. If you don't know the equation between input and output, then go for AI. I'll just clarify the thing that it's nothing to related with the data. Let's say if you have a data as an input, and if you know the output with the equation or any model, any physical means mathematical model, you know that this is the output, then AI is not needed. AI will use same physical mathematical model for their decision. So AI is used when you don't find any equation between input and output. So something like our experience, whatever the decision we give, there is experience decision, there is no mathematical model. So what we do, whatever let's say 3-4 incidents or many incidents happened in your life, you process those kind of incidents, you give weightages to different incidents, and then you combine all those weightages into incidents, and you sum it, and you finally give that, okay, we have to do like this. So there is no mathematical model, fixed mathematical model. So that time definitely go for AI. And as for AI, as there is no direct mathematical model, means you need lot of data. because data is experience to the AI algorithm. So that part is there. So future, you might have heard about that people are even thinking of having chip inside the brain. Anyone heard about this?
Heard about this.
Yeah. So this is called Neuralink, which is run by one of the friends, that is Tesla related company. So Neuralink, what they are doing, that they are analyzing within the brain different, when we talk about our body, it actually releases microvolts and micro, waves. So you can analyze those waves, and on the basis, means whenever the blood flows, it generates microholes. I could say, means if you send something, you can get that into milliholes, microholes, kind of thing. So on that data, they are processing it, and let's say you want to move this glass to this. You think you at the same time this chip is recording all these waves, and then it is saying, okay, that person wants something to move. So next time, whenever you think with this chip in the brain, you just think the machine will operate at. So that is what the future. The second is a augmented reality and virtual reality. So these are two words. Virtual reality means you're totally into animated world. Means if you go to Meta, just you can write down that Meta app. You can easily download. You can upload your photo, and only small prompt can make that video. So that is nowadays available. You can download that and just test. So that is totally virtual environment. And augmented reality means already while walking, you are looking at the nature. That glasses are coming nowadays, where through the nature it is processing with the camera in your glass, and through algorithm it is giving you the alert within the glass. So that is augmented. You are looking at uh, around you, plus you are getting some data on the screen itself. So that is called augmented reality. And you might have heard about this ADAS system, automated driving assisted systems, which are coming to the vehicle, where vehicle can now navigate through the traffic. They stop by themselves. So lot of things. So that is called ADAS. So let's slightly, I'll just put some time here, put some light into AI. Means we started with the automated system, then we made those systems smart, and now we want those systems to take at least some percentage of decisions by themselves, which is happening nowadays. That now in future you will see that this percentage of decision is improving again and again. So when we talk about AI, it has started with narrow intelligence, then general intelligence, whatever we heard about Grok, GPT, Gemini. So everything comes in this general intelligence, and super intelligent is yet to come. That will come. But when we talk about Alexa or Siri, we say that Alexa, switch on the light, or Siri, uh, set alarm for 6:30 p.m. kind of. So this is all called prompt, and it is narrow intelligence. But when we go for general intelligence, where you can ask a question, that I want a solution like this, you make a picture like this, and I want a video to edit like this. So this is general intelligence, where AI is listening to you in human terms. Narrow intelligence means when I say Alexa play song this. So that time Alexa only process play song name. So that is narrow intelligence. So after maybe 5 years, 10 years, slowly we will get we get into super intelligence. So you might have heard about this Optimus robot or Iron robot. So they are like a super intelligent system. So this is a simple thing that all this AI started in 1956, but nothing happened because logic was there, but computation system was not there. So much cost, internet, electronics, the infrastructure was not there. So it has started, everything is put on the paper in 1956, and it started with artificial intelligence. So when we talk about artificial intelligence, machine learning, deep learning, and generative AI, all these are different things. Right? Artificial intelligence is like, I would say, one thing under which machine learning, deep learning, and generative AI comes. And machine learning needs less data. Deep learning, usually called artificial neural network, ANN, it requires huge data. And generative AI means once this data is analyzed, it starts giving you, answers. So that is generative AI. So when we talk about this chat GPT, Gemini, Growth, all these are generative AI. I think this is very simple. That is images, it makes decisions, already talked. So I just want to put, how this AI works. So initially, object definition is of course there. So it starts with the collecting data. Most important to the AI is something like a child. If you give child wrong data, something wrong will happen to his that child's life. But if you give good data, what we usually say, sanskar. So similarly, you have to give a good data to the AI. So AI will map all that data. So making a data preparation and giving to the AI is the prime most thing. If you give a wrong data, you won't get a result, proper result. So if you give a good data, correct data means then you will get a good result. So collecting a data and preparing a data is a big task. And so much of openings are available in this area these days. When we talk about AI engineers, most of the time they are doing this collecting and preparing the data. Once that is there, algorithm is already in place. Only thing is, so many algorithms are available again. So now it's our work for our available data, which kind of algorithms we have to opt for. Again, that decision has to be taken care by us. Once it is there, you have to train the model, means by giving data, process it, then it rearranges weightages inside. Once it is trained, then you put some test model and get the prediction if it is matching with your result. Slowly it is happening. So consider where, as you are using chat GPT and maybe Gemini, the way you are, asking the question, at that time itself also AI starts learning. It gives you the question, answer to your question. And when you say rethink, again it analyzes. So it's like, now it's like a human person. Maybe it is wrong, and again it will process and give you the correct bit by the whatever the experience they have. So machine learning, deep learning, and this is very one more thing which I missed out, that is natural language processing. Machine learning, deep learning was happening. When this natural language processing is really a breakthrough, due to which all these systems now can listen to your voice, your languages, and they can perform. So natural language processing is only to deal with our languages. And the similar, if you look at this, your data input, then there is a relation, it puts weightages inside, and finally it finds out the output. So many layers of intelligence is getting trained so many years. It's actually in our brain. On the same principle, as I said, with our experience, we give decisions. So similarly, if there are some mathematical models, even it adopts those models when there is direct, already proven models plus experience. So both things are getting added. So as I said, the future of AI already, $190 billion of business is going on and it's growing. So I personally feel like even though you all are professors, we have to learn AI. Try to, we at initial phase, you just use whatever the available algorithm, whatever the available platform. I'm just talking about Azure, Firebase, uh, and even AWS. All these platforms are available. You use those. And for even college and students, it is free, totally freely available. So it can be easily utilized. And try to learn this. When we put all these AI systems in our, Rockwell machines, uh, we could go up to 0.1, and in standard, it is written 1% accuracy is okay. But with AI algorithms, we can go up to 0.1%. And 7 days back, we have reached up to 0.01%. Because in mechanical system, after all these calculations, when you go for precision, see from 99.5 to 99.9, to go to that level, it took us nearly 6 months of AI training. So once it is done, we reached up to this accuracy. Now we have reached up to 0.01, 7 days back. So this is, every time learning, and improving. And maybe someone from mechanical, civil, they might be aware of Brinell machine. Initially, there is a lever mechanism and put 3,000 kg, but now it's only small head, fall screw arrangement, load cell, and motor with AI algorithm. You can get this accuracy, 0.05%. I am again repeating it. In our standard, it is required accuracy is 1%, but now we can reach up to 0.05%. Due to this, let's say 20 years back, when people are talking about 1 micron is not so easy, but now people are talking about 0.1 micron nano. So every 20 years, accuracy keeps on increasing. Similarly, we have developed one this is air gauge, which measures the ID. You could see we can give up to 10 nano list count. So when we talk about 10 nano list count in shop floor, even though there are vibrations, even though there is a temperature difference in the shop floor, and maybe wear of the tool, the measurement accuracy doesn't change. So we give up to 10 nano, and for industry, 100 nano currently is okay. But we have developed this technology up to 10. And you can easily visit to Ichalkaranji to see all this. I think I'm done with this in time. Any questions, please let me know. I think, sir, it is up to 7:30, right?
Sir, can I ask a question?
Yeah.
Sir, what is the difference between the artificial intelligence and machine learning, sir?
See, when we, as I said, artificial intelligence is slightly, I would say, superset of machine learning. What happens when we talk about machine learning, we cannot have very huge data sets to capture from one single machine. But when we talk about, let's say, I want to have AI for face recognition, then I have so many data available on social sites or on internet that I can get a fully deep learning system where I can process so much of data and go to a better accuracy. So that is full AI. But in machine, you don't need so much of accuracy, because when we talk about machine learning, we are aware of some already mathematical models. So you don't need to go for all AI treatment into that. Some part you can utilize mathematical models, and some part with same small data set, you can do AI type of calculation. So machine learning is small data, and I would say AI or deep learning is huge data, where there is no mathematical models around.
Thank you, sir.
So, madam, how many registrations are there?
Hello. Tell me, sir. Anybody have questions?
Hello? Hello? Any questions, or should we conclude?
Hello.
Yes.
Anybody have a question? Sir is going to conclude his session. Okay, sir. Thank you, sir, for expressing the beautiful way. It's on rise of.
Hello, am I audible, sir?
Yes, ma'am.
Okay. So, on behalf of Sant Gajanan Maharaj College of Engineering, Mahagaon, I express my heartfelt gratitude to Mr. Nikhil Padte, sir. Sir has beautifully presented the topic Rise of Technology. In the topic, sir has covered industry automation, industry 4.0, industry 5.0, AI, digital twin technology, machine learning, deep learning, natural language processing, the rise of high precision Brenel machine, and many more technological innovations Sir has introduced with us. I hope all the participants have enjoyed today's session. So once again, I express my gratitude to Mr. Nikhil Padte sir. I also thankful to all the participants for their patient listening, and we'll take 5 minutes break and immediately we'll start our second session. Thank you so much, everyone. The feedback link has been shared in the chat box. Kindly fill the feedback link. It will be open just for 15 minutes. Thank you, everyone.
Okay. Thank you. Good night. Thank you.
Thank you. Good night, sir.
Good evening, sir. I'm here.
Hello? Hello?
Yeah, I'm here.
Okay, sir.
I'm sorry for the
So,
delay. Yeah.
it's okay, sir. We can understand. So, good evening, one and all. Once again, for the second session of day 4,
Hello, sir.
ATAL AICTE training and learning sponsored 6 days online faculty development program on design thinking and innovation organized by Department of Mechanical Engineering of Sant Gajanan Maharaj College of Engineering, Mahagaon. So today's second session will be conducted by the renowned speaker Dr. Raghu Ichampatti sir. On behalf of Sant Gajanan Maharaj College of Engineering, Mahagaon, I heartily welcome you, sir.
Thank you.
So the topic of today's session will be product design and manufacture. Before sir will start the session, let me briefly introduce about sir's educational details, academic experiences, honors and awards. So speaking about the educational details, sir has completed BE in mechanical engineering in Andhra University, Voltaire. Also, he has completed a M.Tech from Indian Institute of Technology, Kharagpur, and PhD in Mechanical Engineering from the same IIT, Indian Institute of Technology, Kharagpur. Um, Sir has completed MS in Engineering Management from Kettering University, Flint. As far as academic experiences are concerned, Sir has working as a postdoctoral research assistant, associate, visiting professor, various other universities, assistant, associated, and full professor, Kettering University, part-time professor, Division of Engineering Technology, Vanish State University, honorary visiting professor at IIT Guwahati. Um, Also visiting professor 3 months each during term of at Kettering University of Applied Sciences. Speaking about the industrial experiences, Sir has worked on various funded projects. Bosch professor to conduct airbag injury studies, faculty intern. He has also worked at General Motors Corporation die design and stamping as a faculty intern. GEMA, error and mistake proofing as a faculty intern. Speaking about the honors and awards received by Sir, Sir has received ASME Faculty Advisor Award in the year 2012, ASME Dedicated Service Award in 2013, Fulbright Specialist Award, Faculty of Industrial Education and Technology, Thailand, Erskine Fellowship to teach non-linear FEA at University of Canterbury, Erskine Fellowship to teach non-linear FEA at University of Canterbury, and institutional leaderships and professional services at Kettering, moderator elect and moderator of Faculty Senate, faculty advisor and chair of ASME and Pi Tau Sigma student and senior sections. Sir has been also worked as a chair of promotion ethics and tenure committee. So uh, as we go through the deep portfolio of Sir, we can truly say that today we have with us the very intelligent and very knowledgeable speaker with us. So we are very eager to listen from you, sir. So I hand over the session to today's our guest, Dr. Raghu Ichapatti, sir. Over to you, sir.
Thank you very much. I really appreciate. I'm sorry for the delay. And there are over 90 slides. And at the end of the workshop, they will share the slides with you. And it's very difficult to cover all the slides in 90 minutes because we need to give some time for question and answers also. And so what basically I'm going to do is to run through some slides because there's a lot of repetitions between all the speakers in the last couple of days. And hopefully the outcome of this workshop would be a consolidated like a book that AI AICTE will publish for use by all the faculty and also distribute to other universities. And also, hopefully, we're talking about AI. If you ask AI, if you put all the presentations together and then ask AI to summarize all these presentations, surprisingly, AI can go through all the slides. AI is nothing but a search engine. It's going to read all the materials quickly, and then it can give us summary of all the presenters that presented in the last few days of workshop. You can try it, and it's going to be amazing. So it's going to do something that we can edit, and then perhaps publish like a paper, joint paper, educational paper. Anyways, as I said, I can't spend more than a minute per slide. So the topic I developed a textbook on automotive lightweighting technologies. So basically, some of my talks will the talk will focus on automotive applications. So the main topics of my textbook, and I have other books too on pedagogical teaching and all that. We can always organize workshops, special workshops on engineering design, any of these topics. They can take 1 or 2 days, up to a week. I gave many FDPs in India and also other places. So I'm going to focus more on engineering design, product manufacturing methods, aluminum, and then functional performance. So engineering design has many subtopics. ASME organizes conferences and also all over the world particularly in Europe. Design methodology, design process is very common compared to other countries. United States, we do have this, but there's no single department that's going to talk about these things. So hopefully the outcome of this workshop would be probably to offer courses at the curriculum. So anything you can help, I can help you if you need my help with the curriculum. So the topic is important for design because you see everybody can drive a car. Driving a car doesn't require a PhD. Driving a car doesn't require anything. It's a skill. So therefore, you see automobile or any vehicle, bicycles, cycle rickshaws, scooters, all the mobile transportation is to be properly designed. Okay, so from the automotive and mobility focus, and other speakers also talked about other non or stationary products. Okay, there are many of those. So clean environment and clean environment is very important for the society and to keep the harm less to the people. Now, there are 3 major things. One is the load that's coming on those. Some of them are not load bearing. We think electrical is not load bearing, but we're not talking about mechanical load. Electrical also has a load, amperage, voltage, resistance, and likewise chemical, civil engineering. So there's a load is very important factor. We all know that. And then the second thing is the material. What material are we using for electrical, mechanical, chemical, civil? Material is very important in all our design aspects. And the third thing, so load, material, and then of course we look at the functions and also the geometry. The geometry is very important. It should be concise, compromise. It's very small as much as possible. So geometry, material, load, and also a safety factor. Safety factor is different for amusement parks where the kids are involved. They're using like your amusement park. So safety factor is very important in all aspects. So you heard a lot of terminology in the last few days, in the areas of design and manufacture. So, but the design innovation tools have been used for several centuries, as the previous speaker, Nikhil, also mentioned. Artificial intelligence started only in 1966 or something, right? and that is correct. Look at the word artificial. It's not real. It's an artificial intelligence. So everything is based on need. So we have been doing this for centuries. As he said correctly, we didn't have the tools at the time. And tools means computational tools, all kinds of tools to improvise or improve the products and that are safe. So we have talked about recycle, reduce, refurbish, etc. Will also have been there for centuries. So our ancestors have improvised many techniques to for the food, right? So it's not new for us. So ancestors, they have been doing for a long time in animal kingdom. But not all ideas or patterns make it to production. Please remember that. It doesn't mean that we should stop thinking, design thinking. We should always improvise and make some ideas, because who knows? But not everybody makes into production. Okay, but we all do every day. There are always opportunities, recognition of opportunities for venture capitalists and some of the designers. They're always looking for opportunities to build products based on ideas that are not published. Some are published, some are patented, but they're all looking for opportunities to bring products, useful products for production into the society. Some are small production, some are large production. So opportunities recognition is very important. Okay. So again, go back to the quick slide. Engineering is purposeful. Engineering design is an application of design process and in the field of in the field of engineering. And then there's management. So design is not a subject or a coursework. Design is an activity, and then something should be on your wish list. This also was mentioned by other previous speakers. And there's also personal human content in it and to apply the knowledge. So a typical capstone design class will encompass all these socioeconomic, ethics, and all the other components in a typical capstone design class that I teach, most of us teach. So we have many projects that could be patented, but we just leave them at that point as a class project. We all do that. So not everything makes to patents, etc. Case studies in engineering design, they play a vital role. So when we teach, we always should make use of the internet and then show the ideas to the students through YouTube videos. There's so many available, tons and tons. I show those. So the voice of the customer is someone, and then those are the stakeholders. Stakeholders are parents, you got the companies, we got the manufacturers, we got venture capitalists, management people, and then in some cases, if you do a medical device, there should be a lawyer, there should be a doctor, there should be a patient, and so on. So it's not just enough. We sit down and then improvise or design something that is within the university context only. So I saw many other speakers in this workshop. They took a lot of time in getting their products to the patenting stage. So it takes a lot of efforts, as they mentioned. So the AI tools will not account for some of these voice of the customer. They don't. Remember, AI is only a big search engine. It's going to go through all the literature, available literature very quickly, and then to make modifications to the available literature to what you are looking for. That's not easy for AI. First of all, you need to buy it, any of these AI tools for advanced features that you are looking for. The ChatGPT freeware only has some limitations. For literature review, that's fine. As I said, some of my slides are the result of AI search. including this one right here. And then I don't want to spend again too much time on this. Many other speakers talked about design thinking. We should know it's not a linear process. It's not a sequential process. So there's some iteration between stages. Together, they contribute. So the knowledge and the feedback that we obtain from the previous stage is going to be used in the repetition, in reducing the repetitions of the experimental work. So the design thinking is not really linear. So again, you heard about these things, the different phases, their task clarification and the conceptual design, embodiment design, then detailed design, and then of course you go into production information. And then of course you get the feedback. Now, cost is very important. Cost and affordability for production parts is very, very important. Okay. So without cost reduction, that goes with geometry, materials, and the load that's coming on the product that we are doing. Remember, load is not kilograms. Load is not mechanically measured. So it's electrical. Load could be a number of customers in a bank, number of customers in a bus. So load should be understood in general terms. Now, simulation of the design scenario also it stimulates engineers to model more complex but realistic products. So design activity really requires also a place of work in colleges for the students. We got incubators, centers. I've seen in Vellore. I've seen all the colleges that I visited, IITs. They always is an incubation center for the students to unwrap and do whatever they wanted to do, to improvise. Brain. So previous speaker also talked about brain cells activities. Very important to stimulate our brain cells. Very important. Regardless of patenting, that doesn't matter. Don't worry about this vocabulary. We are using a lot of vocabulary. It doesn't matter. Freely think whatever you wish. So you go ahead and you stimulate your brain, make it. So we need to provide those good facilities and some incentive in terms of the purchasing materials for the students to develop this design thinking. Now, some background obviously is required when you go into details of a product. So many speakers earlier in the workshop, they showed several calculations, engineering calculations. They're all very important because in order to make a product, you need the load bearing capacity, you need calculations, definitely. My daughter recently trying to design a work table for her home, So she has a design constraint. She's a product design background. She has product design background, and that's why she works in this area. So she came up, I asked her, can ChatGPT, any of the AI tools can develop your organizational table? She said, no, they can't. And she said, I'm only getting some ideas verbally, literally, but I'm making my own. And to interface the AI tools with a software like mechanically like AutoCAD, to interface with those AI so that AI can go inside the AutoCAD type tools, CAD tools, to make the changes in the geometry, like dimensions, materials, and to look at what you're specifying verbally. So the voice recognition is another big area. Your accent, my accent is different. So how does a voice recognition, tool can transform your voice, your wishes into a product with the dimensions? That's not still possible. Okay. So you need interfacing with the CAD and other tools. This probably will come. Okay. Again, design process uses other disciplines. Design practice and process influence the quality of life, and it gives a power for richness, variety of cycle. So the flow charts of the design process, you have seen it. There are different varieties of charts which are available. you can go through it on your own when you get the slides. So basically, communication is very important, design communication. And then the prototype that Dr. Sridhar talked about, testing and evaluation, very important, and it's all iterative process. The Gillette Razor, toothbrushes, paste, over the years, there's so many variations. And, making a product outdated is also a design thinking. So they don't want products to last forever. They want always changes. So people actually they're trying to do that. It's an art. How do you make obsolete a product? So obsolescence is very important part of the. But you can see the McDonald's Aloo Tikki burger in Indian market. So it's an improvisation. It's a product, but it's not like a mechanical product, but it's a food product. Very important. You can see other examples. Surprisingly, shampoo, Shikakai, is originally from India. I don't know how many of you know that. So shampoo has been invented in India a long time back. And the cars with the Toyota production systems, Coca-Cola and other beverages, but nothing like chai, right? We call it Chaudhary of chai. When I came from Ahmedabad to Jalgaon, I heard this guy, Chaudhary chai. So near Jalgaon. I loved it. And also if you go to Punjab, their chai is different. Lassi, mango lassi is loved by all over the world. And that's a product from India. Jaipur food, very famous. And there's so many products in India. So many of the new product development, again, it should be consumer centric. That's very important. And then also cross-functional, and it should be structured. And again, as I said, we use the terminology, but there's no bounds. Who's going to follow this process? Brainstorming, brainstorming. Nobody needs to follow this process unless you are trying to make production-oriented parts. So you're free to think. You don't have to follow this jargon that we are using here, design for X, design for manufacturability, etc., etc. You don't have to think about these things. So, but this will definitely enable a systematic process, structured process. Now, brainstorming is a word that you also use, you've heard about many times. So something that causes pain, it also gives an opportunities for new processes, new ideas, etc. We all know that. So don't feel bad about pain, complaints. Complaints is very important. So complaining, feedback, that's what they keep asking us. Banks will ask us, everybody is asking us, please fill up this survey. I'm not sure how much they follow, implement it, but the survey, our survey's feedback is to understand what pains you have so that they can develop new products. Now, there's also a scientific method versus engineering method in a design process. So I gave the difference between scientific method and engineering design process method. So you can again go through that yourself later, but you always communicate the results in either one of these is choices. So let me see. So an example of a scientific problem is simply supported beam mechanical with a diameter circular cross-section pipe is loaded. Find the maximum stress and deflection. This is a engineering science problem. Okay, so you just go do some calculations. You find the maximum stress and deflection. And similar in electrical circuits, how much is the current flowing through it? It's a engineering science problem. But same thing in a design problem is you design a system. It's not now a beam. It's not a circular cross section. You want to design a system for lifting and moving loads up to so much kilograms in a manufacturing facility. So it's like unstructured definition of a problem. So this problem statement is only a hint. Not many hints are given. There's no figure. So it's now it gives us opportunities to design several products based on this example. So the wonderful examples I heard in the last couple of days, speakers, and even today, there's so many fields they covered. I'm really amazed by the other examples, and they all use the principles like 4R, reduce, recycle, etc. We'll talk about that also later, a little bit. So here you can see the creative water bottle wrapped. So there's so many water bottles we all dispose. I'm sure in India also I've seen some ideas about how to use the bottles, plastic bottles. So in Thailand, I have seen this physically when I visited in Thailand, um, Chopra River. Okay, so that comes from China. So when there was flood, people, those who are on the boat, boat also immersed, but this boat made of bottles with this air, with a little bit of air, it never sunk with people. Now, again, DFMA, Design for Manufacturing Assembly, is a method of reducing the manufacturing time. It's also a suite of tools to understand the cost again, and materials and processes that we need to use to reduce the cost and also the recyclability. Okay, so this is from Boothroyd textbook. There are many textbooks, as you know, in engineering design and manufacture. But here's a real example of an aluminum engine side cover. There are about 15 to 30 parts. So they need to design this for compactness. So it's very compact in a certain enclosure, and then it should be light. It should dissipate the heat, and so many functions here. It's a side cover. So you can see the design for manufacturing. It should be manufactured. We'll do die cast it, we injection mold the parts. So that all the questions they have to think about, because the manufacturing machines that also cost too much. So a typical product cost is very important. So the overheads, they're 24%, but the piece product costs are majority, and labor costs should be less. But in some countries, labor costs are much more than even the piece part cost, particularly when it comes to service. If you call air conditioning doctor, everybody is a doctor nowadays. We have a lawn doctor, we have a air conditioning doctor, we have a hair doctor, we got all kinds of doctors now in our society. Doctor, D-O-C-T-O-R. So the labor, in the name of the doctor, they're making a lot of money. They're charging us a lot. Okay. Now, the DFMA technique, the design for manufacturing, should really be focused, because to reduce the cost, I'm trying to get to the pointer. Let me see. So you all can listen to, right? Can you see all the slides, by the way? Can somebody confirm? Can you listen to me? Can you hear me?
Yes, sir.
Yes, sir, we can hear you, sir.
Okay. I just want to
Yes, sir.
Okay, good. Thank you. Okay, now I'm trying to look at the pointer. Okay. So when it comes to production, it takes a long time to make a change. We all know that. And in the conceptual design, the cost and the conceptual design cost is very less to make any changes. When it comes to production, cost is very high. And then also you can't make changes. They're very low. We all know that. So again, this is from Boothroyd textbook. So you can see the product simplification methods. There is also supplier costing. So, but the DFMA, Design for Manufacturing Assembly, with an AI-assisted tool, gives you the chance to better negotiate the price and delivery time of a supplier. That's very important. So you do a lot of products, you come with the product design, but then the supplier, nowadays, they're taking a long time, particularly in United States here. If you want to cut a tree, because we got too many trees in our backyard, too many leaves we have to collect and then dispose. So we need a tree cutter. It takes about 2 weeks. They're all booked. If I want to change my air conditioner unit, they're all booked. So for 2 or 3 weeks. So the supplier to build the products, make a home, it takes a lot of time nowadays because the timber has to come cross the borders with all the tariffs nowadays. So it takes time. So, but the AI tools, they say will reduce time, but I don't think so. We have to do our part in design for manufacturing assembly before we go to a supplier stage. So supply negotiations, again, the textbook basically gives us a product management team, how they design a product. It's an electronic product. They use the techniques to reduce the cost from different stages and different materials using setup processes. So basically they brought down the cost. Again, you can go through these slides and also textbook. If you don't use it, I can help you later with getting textbook. And so in this case, they also want to use a plastic clip assembly. Annual production, again, the production volume is pretty high. The return on investment on software is a simple example, on a single example. So they want to avoid costs of about over $250,000 annually. So they have to do all the cycle here on the left-hand side. You know, first quote and the DFMA technique, suppliers, redefine. So this bracket has to be corrosion resistant, cost is too high, bending stiffness is very critical because they're going to hang some weight, and then whether they want to paint it, and then of course paint cracks should be less, and should you make it out of stainless steel? What kind of process? So this is a classical example. So basically on the left hand side you see a stainless steel. I'm a thick steel 24 gauge versus painted. The cost is different, and then the commodity resin to use injection molding part is less. So they go around discussing how for this part, for the load that's expected on this bracket, injection molding is better. That's what they're going through. Of course, engineering calculations, very important to find the stiffness, bending stiffness in mechanical engineering. So those who are audience here, mechanical engineers or even otherwise, you can think about engineering calculations are very important. So the ABS plastic is here commonly used, and the polycarbonate material is also used. So they're trying to discuss which one is better. There's also thermodynamic calculations for injection molding machine and the part. How long does it take to cool? How long does it take for melting? So the different processes here, thermal diffusivity and other processes, and how long does it take? So the equivalent bending stiffness, finally they calculated versus the cooling time, in this case, with the different wall thicknesses. And so again, all the engineering calculations are mundane. It's really required for process calculations. So the good candidate finally turns out to be the injection molding part for the final design, and what kind of painting, etc. So again, these cases are discussed in depth in textbooks. So now assembly is another technique. How do you reduce the number of parts? And that's very important. And then ease of assembly. How quickly can you assemble? Top down, from sideways, from angle. There are many parts which have to be assembled from the horizontally, vertically, from the sideways. And again, many speakers, as they said, the assembly stations, they keep moving. They keep moving. So the assembly workers, that's stationary, the assembly is moving, so they have to insert the parts very quickly. So these techniques, DFA, again, is a production orientation. We're talking about the design thinking, and if you want to improvise, make a design, and that may not make into production, but that's okay. Remember, you have to stimulate your brain activities. You always keep it active, so we don't get into major diseases that we are recognizing, Alzheimer's, dementia, that people talk about. Now, that's very important. So if you keep your brain inactive, so always think about new things. We always do it. In India, it's a very quick and hot-paced life in India, but still, I keep hearing the unfortunate brain-related diseases. Regardless of the production, you should always keep your brain active. Okay. Shamelessly, I mean, there's no shame in it. I'm sorry. Frankly, my wife has developed short-term memory loss. So, so she is active. She was a school teacher, but still, she has to keep her brain more active, and that's what we are trying to do to her to stabilize. So I think it is very important. All of us do forget. Now we're talking about the design for assembly. So minimum part criteria. Again, the base, you have a fastening function. You need to reduce the number of fasteners or the screws and different materials, relative movement of the parts. So there's all the principles that we discussed. Now look at the gain of a engine assembly. There's so many. A car has, typical car vehicle has about 10,000 parts. 10,000 parts. If you talk about aeroplane, there are millions of parts in aeroplane. So how do you reduce the number of parts? How do you make it lighter? So there's all this struggle going on every day, right? And then also cost effective and it could be scalable. So somebody else should be able to use your approach to design their products, scalability, and also small and big. So how to assemble quickly as the production line moves in a production environment. So that very important design for assembly. Okay, again, there's an example from BDI, means Boothroyd and Dewhurst Incorporated. This is from the textbook, right? So there's so many parts in this simple gadget, and you can see there are sheet metal parts, there are some solid parts like a motor, there are sensors, there are so many screws and the housing. So they reduce all the parts from here by using the DFA techniques. Again, you may not know the terminology, but how do you reduce the number of parts? By thinking the techniques that we discussed, the terminology will help to do in a structured way. And you might come with more than 46% reduction total, which is shown here on the left-hand side. So all this gadget reduced to this. So from here to here, a lot of brain thinking is required together with the process to understand the terminology that will guide us from here to here. Now, if I give it to another brain thinking in India, in China, in Europe, maybe they come with a different product from here to here, the different ideas. So we do this in our classrooms. You give a number of parts in a classroom exercise, tell them how can they reduce the number of parts into a simple product. And so that's a good exercise that you can think. So, so the variety of parts, they come with smaller product that you only define the function, what the final product has to do, and less number of time. You clock it, how long they take. So I think these are kind of exercises will definitely stimulate the brain of the students. I have seen it in Gujarat, I have seen in Maharashtra, I have seen in Andhra Pradesh, Tamil, all places that I visit, IITs, I taught many places. So I got a lot of experience with the students. They're always bubbly, very active. So the separate fasteners, labor costs, etc. So that all the outcomes from the DFMA principles. Okay. Now there is another area called requirements engineering versus design for manufacturing assembly and the conceptual design. Now, requirements engineering is a big field by itself. I reviewed a PhD thesis from Netherlands by a student. It looks abstract thesis, PhD thesis, but the requirements look similar, but the methodology and equations they used looks a little bit abstract, but they do a lot in Europe, requirements engineering. We all do that in order to make a cake or dosha or idli or whatever you make at home. There's a requirement. So you need the tools for it. You need the ingredients for it. So one of the examples here is transportation for student. So the requirement specification, it's also called specifications. So it should be free for students. It should be quick and also safe, and they all operate on time. So I've seen in Gujarat, when I taught in IIT, Gandhinagar, and also other college, Gujarat Technical University. So I've seen there's a separate lane for the city buses because they want to promote passengers to use the bus. Everybody says, well, buses are not on time. They are not reliable. So therefore, they made a specific lane for a bus. Some of you probably already know it. We can't use that lane between certain timings. We also have in USA, United States, other countries, perhaps also in India, on the interstate, there's a separate lane for people that they don't have to take an exit, so they can use it with 3 or more passengers. Some cases, 2 or more passengers in a car, they can take that lane. So these are all the requirements you can put, and then they design a lane, separate lane for it. That's not a product, but that's a product. Product in this case is laying a road, right? Now, we switch gears, go to a functional performance, DFMA. So we talked about design for assembly, design for manufacturing, and then design thinking, etc., design intent. Now, the functional requirements is similar to the requirements, and packaging, etc., is very important. So you make a product, packaging. So when they make, I have seen the Coca-Cola plant in Delhi when I took the students from IIT to the Coca-Cola bottling plant in Delhi. Those a long time back in the 80s. So they drop the Coca-Cola can when it is full and sealed. They drop it from 3 feet above onto the ground, and then it should not open. That's a rigorous test. If you hear me carefully, it's a Coca-Cola bottle. So basically, they shake it a little bit, and then they drop it on the floor. It should not break. It should not open. So that's a typical requirement, like wine bottles, like many other food products that you make. Accidentally, they get dropped down. So they should not harm you, particularly if it is automotive products. You're on a production line. Sometimes the parts fall down. They should not cause any damage to your feet or hands. So that's why the material use very important. So the functional performance is very critical when you make a simple product. So again, for when you use aluminum, the structural stiffness is preserved. Crash behavior, very important. There is a crash and a corrosion. So if you look at the block diagram for the cost model for the integrated cost, again, you're all familiar with product development. There's a process, material, manufacturing issues, and the quality, safety, society. They're all embodied around the vehicle body design. Very important. We need the basic fundamental knowledge, whether it's mechanics or in electrical circuits or chemistry or whatever field you work in, business management, like in accounting. So they're all important, basic knowledge. In this case, we're showing structural. So stiffness and crash behavior, very important. So you know this. Audi in near Pune, I'm sorry, not Audi, ARI, they got a huge test facility for testing the cars, automotives. So if you have a chance, you can request them. They are nice people, ARI people. They can give you a tour of your students. It's amazing to see those. So when there's a crash and crash worthiness, you always do simulation first. And if there's a frontal crash, there are three main things: frontal crash, top, and then of course side impacts, and then the rear impact. So how do you design these structural members? So very critical. So they accordion, just like accordion, like a harmonium, they collapse into this box, but they don't transfer too much of the crash energy to the occupants. So that's the goal here. Okay. Of course, there will be some whiplash, there will be some reaction from the occupants. So belting, seat belts is very important. Otherwise, the kids can get ejected through the window. So, but the question is, Bosch and other companies, they came with very nice ideas to collapse this structure, or they basically use the dampers like a cylinders. So they basically go inside and then they come back again after the crash is over. So somebody has to absorb this crash energy. That's very important. Second is a chain of events in a crash worthiness. So you can see the arrows, how the energy has to dissipate and die down before it comes to the occupant, which is on the right hand side. So there's an YouTube video that we can try to watch. For this, I have to first play the video, I think. And let me see. I have to stop sharing. So let me see. Control. Okay, so before I do that, they told me yesterday what I should do. Okay, so the first thing is, so I need to go back to share, right, sir? Share, and then
Right, sir.
to the video, share.
Go to the entire screen.
Oh, go to the entire screen again? No, to show the video.
To show the video, first go to the YouTube tab. Chrome tab is there.
Go to YouTube,
First,
yes.
yes.
Okay.
Then click on the share button right below in the tab.
Oh, I see. Okay, just a minute. Let me see. I think oh, yeah, here it is.
Yes. Now switch to Google Meet.
Got it. Let me see. Can you see this? Can you see the video? Can you see the video first?
Switch to Google Meet, sir.
No, Google.
Yes. Now switch to the
not here. But anyway, I'm sorry. So let's see. Okay, so basically what it was showing was the crash scenario. So you can go back to the slide, right? So there are a couple of videos that you can try later. It's just a crash simulation. These are available. So I'm back on the slide. Can you see the slide?
Yes, sir.
Okay.
It is visible.
So I'm gonna go to the next slide. So the corrosion is another big area in the design. The other speakers might have talked in a product. So particularly for cars, for vehicles, corrosion very important. There's so many kinds of corrosion. We can spend a whole day on corrosion itself. So the optimal design is the one that basically reduces the cost and maintenance. So the design optimization is very important. So from the corrosion, functional design for functional requirements, and then corrosion and design for optimization is very important. So optimization from the cost and also the risk and other things. So again, analysis has to be done for reducing the maintenance costs. So in order to get the uh, cost versus the total impact and risk here, so then there's an optimum basically uh, time that requires to get the ROI. Now, design for reliability is again another big area. So all these things were gone through by the speaker, Deshpande Saab. I think somebody who talked about product patenting. So they went through all these different cycles before they got the patent approved by any country, United States or India or whatever country. So reliability is very important. So the design for reliability is again integrated activity. And so it should be reliable. So some people use the word robust. Robust means there might be slight misuse of product beyond its operational conditions. So we always slam the door of a car when we get mad, or when there is a traffic coming on, you want to close the door quickly for your car. So you slam the door, right? But it doesn't mean the door is crashed. The door is not spoiled yet. So they do testing for reliability and also robustness. So there's always some people press the brake hard, some people gently, some people steer quickly. So it depends on the operation conditions. So it should be robust and reliable also in terms of time. So design for reliability also follows the same kind of idea, but you need to identify the reliability aspect, and then you go to the design. Again, you do the analysis, verify, and you do the iterations always. So again, reliability versus cost. Again, a lot of mathematics, a lot of calculations are required for production-oriented parts. So I think these are small activities with small, minor, simple calculations one can do in classroom when wants to define a requirement or problem definition and ask the students to make something. These are typically possible in a capstone design class. Capstone design class is usually pushed to the last class in the semester in their curriculum, 4th year. I don't agree with that. That's too late because students are ready to graduate. Well, some people say, well, they acquired the knowledge now and they want to use all the knowledge learned, mathematics, science, business, into this class, capstone class. That's true. But then maybe there might be 2 capstone classes, one somewhere in the 3rd year and once again in the 4th year. Now the capstone class should be multidisciplinary. It's not limited to only mechanical, only electrical. It's not subject oriented. You should have a consolidation of different students from different classes, different disciplines, different areas, electrical, mechanical. I think we're all doing it nowadays. Very few universities allow mixing students from different disciplines into a single course. There might be, but I've seen IIT Gandhinagar does it, Vellore Institute of Technology, some other schools, IITs. I try to do it in my class too. So I think these are important. Now, sustainability, life cycle assessment, very important. So sustainable development, it requires the compromise for future generations without compromising. So we need to make products so that they're useful for future generations. And so we are not doing good justice, in my view, in inventing too many products, cell phones. they're all changing every day. They change every day, the technology. So they're not sustainable products. Most of them are corporate healthy. Corporate healthy means they want to make money. Many products are made to make money and business. I think that's unfortunate. But um, that's one aspect. Somebody has to make money, but there's a disparity and bipolar financial gains. Some people are getting too rich, people are staying in the middle, some people are still poor. So the sustainability is not taken into account most of the time in the products and processes. So they need to be careful. So there should be environmentally friendly, sustainable products and also green revolution. We talked a lot about those biodegradable, recyclable, etc. So for a manufacturing in automobiles, again, materials, energy, and then the waste management, very important. You have seen similar flow diagrams in many textbooks, or you might teach this from other speakers. They're all nonlinear operations with closed loop, and then they keep on iterating. It's a product life cycle analysis, LCA. We did it many times in classes, LCA. LCA is starting from cradle to grave, they call it, right? So starting from inception of the idea, you make a product, what tools comprise to make the product successfully launched, and then how do you dispose those? So they're all very important in the LCA, life cycle analysis. So this will engage the students extremely well. Okay. So I show them, for example, videos of how the butter that you use, butter, butter, like Amul production and dairy. I took them there too when I was teaching in IIT Gandhinagar. So Amul production unit, excellent unit. They use a lot of principles and very healthy, hygienic, and you can show the videos how butter is made, packed, and students can understand the process. They can also understand the machines, how they design, how the machines are designed, because you're making butter, which is a food product. So the machine components, they are steel, they're not aluminum, they're not other plastics. They might be, but material, manufacturing machines should also be food friendly. Otherwise, you can't make food products. So the Food Drug Administration, they don't approve those. Same thing with the medicines, making equipment. So, and then how do you dispose those? Very important. So again, what's the function, what's the material, and how long does it take, how much it costs, where does the waste go? And does washing the China means not country, China means China material, and what type of data is required to understand the recyclability aspects. So the global warming is a potential problem, and abiotic depletion. So we also have the human toxicity potential. So that should be reduced. How much land is needed, and so on. So I think I'm surprised that when there are speakers at IIT Gandhinagar from United States, they're talking about environmental aspects and recyclability and so on to the students. I asked the students, do you understand the lecture? And because the speakers asked for my comments, I asked the students, do you understand the lecture? They said yes. I said, if you want to do something on your own where you're living, what is that one thing you can do to keep environmental friendly? What aspects, what activities do you do? Paper, taking shower, etc., etc. How much water can you use? Because India sometimes has problems for water. Sometimes it's flood. So water management is very important for all countries anyways. Not many students responded, but afterwards, few students thought about it. And then they said, yeah, they got nice ideas. So after the workshop was over, they were really ready to share their knowledge. So I think, again, keep the brains active is very important. There's so many categories of environmental impact, and I'll just show this slide. You can read quickly. And smog, we always have problems here in California, Delhi in India. We got a lot of problems. That's why the electric vehicles are coming in. We're not sure the battery recyclability. I'm glad to see that India is now third world's largest electric vehicle battery production units in Gujarat. They're making it. So I'm glad to hear that. And hopefully that will reduce the smog and other things, but recyclability and the cost involved in electric vehicles, running, maintenance, so that needs to be thought about by all countries. So where do you go from here? Basically, scientists can make recommendations, so that will be less impactful to the society. They can analyze. That's why the scientists come into picture. Industry individuals can take a closer look. So we can again take two products for the classroom, and then you can do LCA, life cycle analysis methods. Now think about the automobile with 10,000 parts in automobile. So start from inception, idea to recycle stages. How do you recycle all these products? Some of them are remeltable, some of them you can dispose, but they have to think about it right now. Seats are made of foam and different plastic items. How do you dispose those? So they're all now very important aspects. So the more applications in automotive, as you can know, they're all here. So they may not be important to all the audience here, but automobile is a very good example, because you and I can drive a motorcycle or a bicycle or a car or ride a bus. Now again, I was talking about the production machines that make these products. They have to also be carefully designed and fabricated. I'm talking about conveyors, the rollers, all the machines, motors, all the structures that you see in civil engineering. There are codes in it. And then the final product here is to make the roll of sheets, right? So these sheet rolls are used for car body. And but in order to make it, you got this huge facility of the company. And so that also has to be designed carefully, less volume, less space, and so on. Now, 3D printing technology is a huge area. I also heard some other speakers talking about it. So this is another tool for developing your brain thinking ideas. So you can use 3D technology, which is very cheap, and sometimes it takes time to make a product, but functionally useful products are difficult to make by simple 3D printing technology. So now they're mixing materials, metals. So again, there are so many conferences I attended, some lectures, simple lectures with my limited knowledge. And I'm glad to organize anything in this area. Serial lithography, additive manufacturing. There's so many students. They have desktop factory. So many students here in USA, and I think also in India, you can buy a 3D printing tabletop machine. So you do a lot of things. Now remember, the students are different cross-sectional students. Now a student with a D grade or a C grade, it doesn't matter what grade the student is getting in your class, but some of the students are very, very innovative. So they don't like your subject, what you're teaching in a class, like Einstein. He never liked the classes. So we teach in a certain way, but it doesn't get across to all the students. You always have to look for some students who are different, and then they may be more innovative. And oftentimes that is true. I got many students in IIT Gandhinagar. I'm talking about India, but also in the United States. They don't listen to the classes, but they're doing something else. And in Gandhinagar, one of the students, he said, "Sir, I understand what you're talking about, but I want to come with my own project for the class." I said, "Sure, what is it?" He wants to make agarbatti making machine. You know about the story about agarbatti make machine, and he's from a village, and then he wants to help his village women and other people in manufacturing a machine so that they don't do it with hand. And he finally came with a machine 1 year later, and he got an award, national award. So I know that this student was not very actively participating in the class, but he did all the calculation. He is capable given time, but his interest was slightly different. Always look for those, and he used a little bit of 3D printing to make his machine. Potential applications, medical devices, etc. And I have a student in capstone class. They make a prosthetic foot example, like Jaipur foot. Okay, so in this case, they this is a real 3D printed machine, but they started with the conceptual design, many stages, many iterations, many CAD drawings to make analysis, final element analysis, design calculation. They got springs, they got bolts and nuts, little bit, not too many. So they did the DFA, DFM techniques to make this preliminary design. I have to involve many stakeholders. I have to involve a biomechanics professor from New Zealand who helped us. We used some codes and standards for foot. I involved a foot doctor who is locally practicing here. I involved a patient who actually uses a foot, artificial foot. And we didn't test this on the patient though. We got the feedback from the patient. We showed this product, and the patient gave us the feedback. And also we have a lawyer, and then we have the manufacturer, student, one of the students, entrepreneur. He became an entrepreneur. So he opened his company. So he helped us make this product. So there's so many stakeholders you have to think about always in a product. So there's so many other examples. NASA, there's so many applications. Some are stationary, some are dynamic environment. And so you can go through quickly, the slide again on your own. Now, AI tools and other lightweight materials will slightly help. Now, many of you ask questions about AI, how AI can be used. So remember the word artificial is not real. Remember our ancestor, chimpanzee, I showed you in the beginning. So chimpanzee is real, intelligent to poke small stick into the termite or ant hill to get the ants to eat. So it's a real intelligence, improvised design of a stick. There's so many examples that experimentalists make with crows, with wild animals. You've seen some of those videos. So we all think that animals are dumb, D-U-M-B, dumb. That's not true. We're learning every day from nature, from animals. Remember that. So they give us lots of ideas if we really watch them. Okay. So AI is a fast Google search engine. Remember that. Okay, please remember that. It cannot give us real manufacturable products. What's in your mind? It can't yet. It takes a lot of interface with algorithms, software to do some of these things. So don't anticipate too much. It's artificial. It's not real. Now, AI tools can enhance creativity and, of course, precision product. It gives ideas because AI is going to generate multiple design ideas verbally based on the constraints and sometimes through pictures, but unless they have interface with the software tools, they can't make a drawing for you. They cannot yet. A time will come, the CAD integration and testing. So predictive maintenance, and so it can give textural feedback and in robotics or process optimization. So AI can help us, and definitely we need to use that. But limitations, as I said, voice of the customer, and then the voice of the stakeholders, they play a vital role, but the AI cannot do that. Okay, and things that are not published, nothing is published yet, are not available in the literature. What can AI do if nothing is published? Because AI is going to search first the available literature before it can come up with its own ideas. So the current and perhaps future AI tools may not be able to account for those without interaction from us and their team members, and also interface with the engineering softwares. So many case studies are presented for the maintenance to produce manuals. So rather than you writing a manual, AI can draft a manual components. How do you make the bill of materials? Quality control standards. You can ask for it. It'll give those building codes. So you can get those. You can give all that like a Google search engine. AI tools can do that, and then you can go through it, and then you can actually correct those to suit your needs. So the future trends will be materials research, very important. What materials should you use? Real-time digital twins, autonomous vehicles, IoT, you call it, and then human AI collaboration. In so AI revolution in products and costs, etc., but still it has limitations. So now I asked AI tool, ChatGPT, to give me a drawing of an automotive piston, only piston. AI gave me the whole drawing of not only piston, if you identify those who are familiar, that's what I'm asking, only the piston. He gave me connecting rod, he gave me the connecting rod details. I asked repeatedly this question. Maybe my questions are not correct. Maybe you can try it later. You only want the piston for the AI to give you. So AI gives more than what you're asking. So if you put a quiz on a test for the students and you're worried about students may copy, use ChatGPT, well, they might get different answers. You're asking for a piston and they'll submit this drawing. And of course, they lose points because you're only asking for piston drawing. You know what I'm saying? So if they cheat and use AI, and then of course it's going to give a lot of other information that's not correct. And same thing I tried for drawing of RNC circuit. So it gave me a lot of information. Of course, on the right-hand side, there's RNC circuit. Left-hand side, it's more information than what I asked. And what I'm saying is, this is not wrong, but what AI does is to search the literature and then give the image for it. But if you say, I want a circuit to make an amplifier of a certain type and give me all the specifications, it might be difficult at this stage. So again, I repeated the same thing. I'm concluding my talk here. We use a lot of tools and terminology in the last few days, but don't get bogged down with process, terminology, etc. Don't worry about it. Somebody has to put some terminology in English or in Hindi or whatever language. Don't worry about it's a structured process, will come later. But in the meantime, definitely innovate, improvise. You think about what you want to do. It's on your wish list. That's very important. That's what all the speakers told us. What do you want? What do you like? What do you wish? So the wish list is very important. And then what is it paining? What is it bothering you in your daily life? Not only products, processes. So don't complain. Check the complaint and try to come with an idea how to solve it. So complaints are very important. Complaint very important. How to solve it is more important. So it's a humorous but factual example. So here is a couple from, of course, the internet, and it's a married couple. So they were to be sent by the parents. Say, hey, Sukhi raho, apna ghar jao, ghar sambhalo. We kept your nice apartment in Bombay or Chennai or Delhi. Apartment ready hai aapka. So jao, your refrigerator is there, sofa is there, everything is there. Enjoy your life. We wish you good luck. And then that's what newly married couple. But the bridegroom, the man, basically he's collecting a lot of torn clothes Then of course the parents were worried. Arey beta kya ho raha hai? And we gave you nice clothes, box full of nice, good clothes. Why are you carrying all these torn clothes, torn dhoti, torn shirt, torn sari? Why are you carrying all this? He said, sir, you gave us new house, new thing, but pocha karne ke liye, I have to clean the house and I have to look for some cloth. So it's improvisation. I want to refurbish, reuse a torn cloth to clean my house. Otherwise, I don't have nothing. I will go to market, buy all the cleaning stuff. In the meantime, that's why I'm collecting all the torn clothes. So it's just a humorous example, but it's a factual thing. So we talked about many subtopics in my lecture here. There's so many references I gave here. It's not full. Even many speakers, I should have referenced them too. So if you use these lecture notes, these slides, definitely you can add those, update this, you can send it back to me. And anybody interested to collaborate with any of us, me or other speakers, please do so. We'll be more than glad to work with you to come with anything that you want from me. Um, I might visit India next year sometime. I'm always interested in stopping by any of the colleges without any of your financial commitment. So I'm here to help you. So with that, we still have another 7 minutes. I'm sorry I rushed through all my slides very quickly, but you will get the copy of those slides. And so if you have any questions, more than glad to discuss those. Thank you. Sounds up? Yeah.
Thank you so much, sir. Participants are requested that if you are having any questions, then you can ask to sir.
So I'm seeing nice comments, but if you have any questions about, I'm sorry again, I rushed through many slides. And if you have any comments or feedback, feel free. Um, you forgot to give me an email, but I request Sanjay Sound and the organizers to share my email with the participants too. Anybody interested in contacting me. So I'll be more than glad to help you all.
Sure, sir. Sure. If participants are not having any doubts and queries, then we'll sum up the session. Uh, so, on behalf of Sant Gajanan Maharaj College of Engineering, Mahagaon, I express my heartfelt gratitude to today's our speaker, Dr. Raghu Ichampatti sir. Sir has introduced a very deeply and very informative topic, product design and manufacture. Sir has introduced design methodology, design process, design for manufacture and assembly, design for functional performance, design for reliability. Also, sir has introduced engineering design, material considerations, basic mechanical and physical properties of aluminum. So all the points sir has covered very nicely. So once again, I am very grateful and thankful to our renowned speaker, Dr. Raghu Ichampatti sir. Also, I am very thankful to all the participants for their patient listening. So we'll share the link in chat box regarding the feedback. All the participants are requested to fill the feedback uh, within 15 minutes. So before end of the session, I request all the participants to kindly turn on their webcams so we can take some snapshots.
Yeah, I think you should.
But,
And
yeah,
thank you.
but
Yeah.
thank you, sir. Thank you so much. Good night, everyone. Before that, participants are requested to turn on their webcams so we can take some snapshots.
Many are shy. I gave lecture to China, students in China. There are 75 students.
Yes, sir, sure.
Yeah, none of those turned on their videos. I was worried. I only see 15 participants in the list out of 75.
Maybe
So I was worried.
participants are at their home, so they are not comfortable. It's okay. Those who can turn the cameras, webcams, they can turn it on.
Yeah, I was
Thank you so
saying
much.
that the Chinese students are very shy. They don't want to show their. And when they took the exam, almost all of them they got B or better, B or better. I was surprised. And what they're doing, very nice idea. When I'm talking, one of the students told me, "Sir, only 20% of us understand English." Then I said, "I'm speaking all the time in English. How do you understand this, my lecture?" They said, "Sir, we understand your equations. There's no problem with that. We understand your equations. But what about my lecture part?" They said, first of all, there are 75 students, not 15, because there are huge TV screens inside the auditorium that they're taking class remotely in China. I'm here during pandemic time. So they got huge screens. And so they said, not all of us can afford laptop. So only 15 of us or 20 of us, others are sharing with us laptop. And but I said, how about my lecture content? They said they're using transcribing tools. What that means, I'm speaking in English. It's not the voice recognition I told you. So the English I'm speaking is translated into Chinese. So what they're seeing when I'm talking, it's all transcribed, closed caption they call it. That's in Chinese. So that's what they're doing. So that's how they understood the lecture. Then I asked my American local friend, "Can you speak and transcribe?" Well, his is also, his or her, is not 100% transcribed, which means whatever he's saying, the transcripted algorithms, they're not exactly putting all the words, but definitely 80%, 90%. Mine might be 70% because some accent. So accent that's a robust transcriber. So it should understand Marathi accent, Tamil accent, Andhra accent, Punjabi accent, Bombay accent, Netherlands accent, Australian. So there's so many accents we have for the same word. So how does this voice recognition people transcribe that into the same word? That's very tough for them to develop that voice recognition tool. So it's very amazing for me to understand that. But anyway, the Chinese students did very well. So I know that some of you did not turn on your camera, but I know you're patiently listening all the 3 days or 4 days. And hopefully the outcome of the workshop is you're going to float or offer new class or a new topic in your curriculum. That's what I'm thinking, the outcome. So we'll find out. I wish you good luck. I really enjoyed talking to you guys. And I really thank you and good luck for you. You have another day tomorrow or this is the last day? And I forgot to check the schedule.
No, sir.
Still, we have 2 days.
2 more days. So I'll try
Yes.
to join as much as I can.
Okay, sir. I'm glad to hear from you, sir. Thank you, sir.
Thank you, sir.
Thank you so much, sir, and thank you all the
Thank you.
participants. And good night, everyone.
Good night.
Thank you. Thank you.
Thank you, madam. Good night, madam. Okay.